Hello and welcome to the last part of the MCE Adapter special. In the previous parts, I explained a lot of stuff about gbs-8200, why it doesn't work with CGA and EGA signals, and how I built my MCE adapter to work around the issues. I explained some theory and how this adapter works. If you didn't see previous parts, please watch them first. And in this part, it is all about practical tests and use cases of the MCE adapters. But before I show how it works, let's take a brief look at the test hardware. For the development, I used mainly three graphics cards. First one is a very nice CG8 Hercules card. It has overwhelming 64 kilobytes of video memory, a parallel port and optional serial port, and optional composite output, which are irrelevant for this topic, but worth the mention. The second card is the EGA and VGA graphics card from Oak Technologies. It is built around an OTI 067 chip, has two output options, 15-pin VGA and 9-pin EGA. This card has 512 kilobytes of memory, which is enormous for an EGA card, and it is very fast. I guess this is the fastest EGA card that I know. The third card is my little treasure. Maybe you saw my video about resurrection of this one. This card has also two output options as the last one. It has 256 kilobytes of memory and is super slow. But still, I'm very glad to have this card in my collection. It has a bunch of switches which provide a huge amount of settings. Take a look at the manual. Alone this manual is like a jackpot. It contains huge amount of information about different monitors, video modes, frequencies, resolutions, and so on and so on. Furthermore, on the page 17, it contains a table with switch settings, and this is absolutely mind-blowing. This graphics card has a lot of options for the type of connected monitor. It supports digital monochrome and color displays for MDA, CGA, and EGA, but also multi-sync TTL and different analog RGB and VGA compatible displays. On the other hand, it is possible to set the graphics card in auto mode to select the video standard automatically, dependent from the display type, or to tackle this video standard to a specific type. For example, it is possible to set the graphics card to EGA mode, but tell it that it is connected to CGA compatible monitor, so it only provides 15 kHz 16 color EGA modes. This wide range of settings is something really unique. The card supports MDA, Hercules, CGA, 16 colors EGA, 64 colors EGA, 256 colors MCGA, and last but not least, VGA. Okay, let's connect the MCE adapter to the gbs-8200 and see what we get. First graphics card will be the Hercules and CGA compatible one. It is set to auto mode, so we can switch between Hercules and CGA from the software later. On the MCE adapter, I'll set the first jumper to color, second jumper to unset, since CGA can only 16 colors, and the third jumper for sync inversion is also unset. And this jumper is set to composite sync. Now, one end of the adapter is connected through gbs-8200 to the monitor. The other one goes to the graphics card. And here you go, we have a CGA output on a VGA monitor. In BIOS, you already can see the brown color, which I will talk about a bit later again. The graphics card was detected as 80 columns color output. In Checkit, we can see CGA video adapter in test. Checkit has also some video tests for text and graphics modes. Let's start with text mode. As you can see, all characters are okay. We can see different colors, also brown. In this test, we clearly can see the difference between white and gray colors. Here you see an overview of all text fore and background colors combinations. Unfortunately, gbs-8200 obviously has to struggle a lot with some combinations, especially brown on green doesn't look really good. And here are the graphics modes. Everything looks good. Sorry for recording the screen through camera again, the colors seem not to be transferred properly. But just believe me, the ugly color palettes are looking right, even if they are as ugly as always. Anyway, I just wanted to show you that it works on a real monitor as well, but because recording through camera is actually a bad idea, I bought this VGA to HDMI adapter and a HDMI to USB video capture device, which I will use now for further demonstration. Let's take a look at some games. Here is Paku Paku, and it is especially interesting because it uses 160 by 100 video mode, where CGA is able to make use of full 16 colors palette. And as you can see, all colors are right. You also can clearly distinguish between bright and dark colors. Prince of Persia is a game which supports the ugly CGA 4 colors palette and runs in 320 by 200 resolution. The game runs flawlessly as well. However, the image is a bit blurry and there is some kind of shimmer around moving objects. But with such a chain of converters, with the graphics adapter itself, my MCE adapter, gbs-8200, VGA to HDMI, and the HDMI capture device in the end, it makes it a little bit complicated to tell what exactly impacts the image quality and how much. At least on the monitor, which was connected directly to the gbs-8200, the image was a lot sharper. What makes me think that the VGA to HDMI converter could be one of the reasons for blurring. CGA was supported by many games. Another example is Eye of the Beholder, which also runs absolutely fine. But it is time to switch from CGA to 15 kHz 16 colors EGA. I will limit the graphics card to low resolution 16 colors only mode. As you see, BIOS detected the card switch, and Checkit reports EGA as well. All the CGA compatible graphics modes do work, and here is EGA 16 colors 320 by 200 mode. Also here is the brown color, a special case like in CGA, and here is 16 colors mode once again, but in 640 by 200 this time. And here is Prince of Persia in EGA. It was kind of stupid from me, but unfortunately I recorded everything without sound, because my test setup didn't have any sound card installed. Anyway, the image is again not perfect, but actually quite good. By the way, my MCE adapter has no buffers at all. It nearly instantly converts the input to the output, so there is no measurable delay. Whole delay is therefore defined by gbs-8200, VGA to HDMI converter, and the HDMI capture device, which probably will be quite high. However, I could still play Prince of Persia flawlessly. And another nice game with EGA support is Commander Keen 4. It is very colorful, but uses a lot of brown color. So it is important here to have a proper brown color conversion. What I would point out here are the vertical jail bars, which you can slightly see in this game. The creme de la creme of the tests for EGA is the game Lemmings. Look what happens if I start it. The main menu is completely messed up, but as soon as I press F1 for new game, I'll end up in a pretty good looking first level of the game. But what happens there? Well, the menu of the EGA version of the game uses 64 colors high-resolution EGA mode, despite that the card actually is set to support only 15 kHz compatible low resolutions. The game seems just blindly to assume that this mode is supported if EGA version is in use. Most of the games didn't do such things and ran into CGA color monitor friendly 16 colors 320 by 200 modes even in EGA. We will come back later to this issue. Another very popular game which I'd like to show you is The Secret of Monkey Island. It works, but the vertical jail bars here are extremely visible. As I saw them first time, I was not sure if my adapter or something else is responsible for the jail bars. So after a small investigation on gbs-8200, I found a lot of references to the open source alternative firmware for it. Many people promised a lot better picture quality and less latency, so I installed it on one of my gbs-8200 devices to see what I will get. There is plenty of information about it online, so I will not go into details. However, this gbs-8200 on the right is modified to run with gbs-control software, which is installed on an additional microcontroller, which is plugged into the gbs-8200. It overloads the internal software and should give us a lot better results. I will put a link to the gbs-control project down below. And would you look at that? You can see it on the first glance. The image is a lot crisper. The fonts look better. Here you can see that the brown on green has a lot more contrast than before and is actually almost readable. Also, the colors have a lot better definition. In Prince of Persia, the image is also better. The shimmer around moving objects has also gone. I didn't measure the latency, but at least it didn't get worse. The game is still absolutely playable. And as you see in the Secrets of Monkey Island, the jail bars disappeared and the image is absolutely clean. And now the complicated case, Lemmings. As you can see, the main menu still seems not to work, but in the game itself, I have a feeling that the colors have higher contrast. And again, back in DOS, just look how crisp the fonts are. Another benefit of using GBS control software are sync frequencies beyond 15 kHz, which original GBS 8200 firmware exclusively supports. If you remember, MDA runs at 18 kHz horizontal sync and 50 Hz vertical sync. High resolution EGA, on the other hand, runs at 21 kHz and 60 Hz. Both modes are far away from supported 15 kHz of GBS 8200, but GBS control should be able to handle that frequencies if you believe some statements from the internet. So let's check it out. Time again to change the horse and use the Hercules capable graphics adapter. If switched to auto mode, you can select between Hercules and CGA in the software. The machine is now running in CGA. Prince of Persia has in the setup an option for Hercules, so let's give it a try. As you see, GBS 8200 struggles a lot to synchronize at 18 kHz. Well, with GBS control, at least it tries to get there. With the original GBS 8200, you would just get black screen at this point. Anyway, after some struggling with synchronization, GBS control got it to get in sync with 18 kHz. And voila, we have Hercules up and running. And using the second jumper on the MCE adapter, we can select between black and white and black and green colorization. Kind of emulating the old green screens if you want to. And as you can see, the latency is quite okay as well. So I could even win the fight without a problem. So the MCE adapter runs with MDA, CGA and low resolution EGA so far. What about 64 colors high resolution EGA? Let's again change to the EGA card and see what we get. Well, this doesn't look very well. After restart, we can clearly see that the image is in high resolution, but the image is very unstable and is heavily out of sync. As soon as it was stabilized and I tried to start something, GBS 8200 instantly got out of sync again. So I couldn't make any proper tests in this mode. The problem is not the MCE adapter, but rather GBS 8200. The explanation will follow in a moment. And now let's come back first to the brown color to point it out why it is important to have proper brown color representation. I removed the brown color hack from the MCE adapter firmware and made some screenshots with and without the hack for comparison. Here is checked color table and how 16 EGA colors should look like. This is how it looks like without brown color hack. Especially in games you can see how bad it looks like if brown color is wrong. For example, Prince of Persia. Here you can see greenish-yellow skin of the protagonist instead of brown. And during some games like Lemmings still look okayish without proper brown color. Others like Commander Keen do look awful. By the way, many modern graphics cards don't have the brown hack in the deck anymore. And if you start the good old DOS on a modern machine, yes, it is still mostly possible, your games will probably look like this. Okay, so far I was talking about the MCE adapter as a CGA or EGA to analog RGBS converter to use it with the GBS 8200. I hope I could answer some questions related to that conversion. However, is this MCE adapter only some kind of add-on for GBS 8200, or can it be helpful in some other ways as well? Oh yes, it can. GBS 8200 is just a possible use case, and in my opinion, not the best one. During the work on this project, I tested the MCE adapter with some VGA monitors which support frequencies below the standard 31 kHz. Long story short, my new monitor in the workshop is this NEC Multisync LCD 1970NX. This monitor can handle all required frequencies above 15 kHz horizontal and 50 Hz vertical. So I don't need any GBS 8200 anymore. To connect my Hercules, MDA, CGA, low and high-res EGA PCs, I just need my MCE adapter, which I can plug between the graphics card and the monitor. This is it. Without GBS 8200, the delay is limited to just the analog to digital signal conversion inside of the monitor itself, It depends on the monitor, but it is really minimal. So if you have a 15 kHz and above capable RGB or VGA monitor, using the MCE adapter you can connect it to all of the old machines. Unfortunately, such monitors are kind of rare and it takes time to find one, but at least you can find some for normal prices. I will put a link below to a list of 15 kHz capable monitors. I guess there are more such monitors out there, but many were just not yet tested or discovered as 15 kHz capable, since many of them don't tell about it in the specification. Enough talking, just let's connect our EGA graphics card through the MCE adapter to the monitor and finally see if this mode is working as well. By the way, this is where the C-Sync and HV-Sync selection jumper comes handy, because this monitor needs HV-Sync and not Composite Sync. However, many RGBS monitors do actually need Composite Sync, so it was very important to make it switchable. And here you go, we obviously have high resolution EGA, and check it tells us that EGA was detected. As you can see, check it switches between CGA, low and high resolution EGA modes all the time, and the monitor eats it without any problems. Sorry for the colors again. Filming a screen just doesn't work well most of the time. I just have to add that the colors are good, and the image is as sharp as it can be on a TFT with such a low resolution. The brown hack, which is activated for 16 colors, must be deactivated for 64 colors mode, where separated intensity signals must be taken into account. This is done by setting the jumper at second position. Here you can see how brown color changes when I switch 16 and 64 colors mode. I think I still owe you an explanation why high-resolution EGA didn't work with gbs-8200. Take a look at frequencies which the monitor reports. With CGA and low-resolution EGA modes, it says 15 kHz. But with high resolution, it tells 24 kHz instead of standard 21 kHz. I measured the frequencies with my oscilloscope, and I can confirm that the card delivers 24 kHz instead of 21 kHz. Indeed. Unfortunately, both of my EGA cards deliver frequencies somewhere between 22 and 25 kHz. However, gbs-8200 supports in the unmodified state only 15 kHz, and using gbs-control 21 kHz seems to be an absolute maximum. 24 kHz is way out of this limit. That's why I couldn't get any image using it. The question is, why do this card deliver so high frequencies? This remains an open question. Time to eventually move on to the most complicated EGA test again, lemmings. As you can see, MCE Adapter does the job, and we are getting all 64 EGA colors in 640 by 350 resolution. Here you can see me switching between 64 and 16 colors on the MCE adapter. You can also see that in the menu it runs with 24 kHz. The resolution seems to be also odd, or the monitor just detects it wrong, I don't know. Well, I'm not sure. Anyway, as soon as we are in the game, the resolution changes to 320 by 200. As you can see, the sync has dropped to 15 kHz and the colors are wrong, because the adapter is still in 64 colors mode and I have to switch it to 16 colors back. This is really annoying that you have to switch the colors manually. Most of the real EGA monitors back in the days switched the colors automatically when in high resolution mode. Integrating such logic into the MCE adapter would make things a lot complicated, but maybe this is something for improvement plans. And after all, some monitors back then also had a manual switch as well, so it makes it half as bad, I guess. And this is actually it. The MCE adapter works for MDA, Hercules CGA, low resolution and high resolution EGA. It can convert 2, 4, 16 and 64 colors to analog RGB. It can calculate composite sync out of HV sync. It can also loop HV sync through. It can handle positive and negative sync signals. And it corrects the brown hack for CGA and 16 colors EGA modes. It even have a small fun feature to switch between green and white screen in monochrome mode. You can use it to connect your old PCs to modern VGA monitors and TVs, either directly if they support the frequencies or through a gbs-8200 or similar devices. By the way, one of my plans was to integrate the MCE adapter into this SCART to HDMI converter. I usually use it to connect my C64 to my monitor, It would be cool if I also could use it for the old MDA, CGA, and EGA PCs. Well, one day maybe. Believe me or not, this project was extremely resource consuming. All the specs and hacks, like with brown color, I bought multiple monitors and GBS-8200s for testing, and PCBs, parts, etc. But the main thing, it was a lot of fun. And it ended in something very simple and hopefully useful for the community. As I told, everything you need to build such an adapter yourself is open source, and you can find a link below. There are some other similar projects out there, but they are usually more expensive and sophisticated, as this one. And for a simple use case like reusing a 15 kHz analog monitor with some CGA 10D or what, it is absolutely sufficient and costs only a couple of euros. And this is it from me for today. I hope you enjoyed it and found it at least informative or maybe even helpful. Just as always, please don't forget to leave your feedback below. If you like my channel, please consider to subscribe if not already, to share my channel, or to help in any other way you can. So far, thank you and goodbye.